Okay, I'm liking the conversation. You can continue your conversation. I'll be there with you in a bit. I'm here. Actually, just came in just a bit from work, so I am sort of just sorting out my lineup for the show. So just give me a bit. I'll be right here. Continue the conversation. It's always nice to know each other. Remember that you're not supposed to exchange your personal information online, because while we know each other by the various names that are here, indeed we really don't know each other. All right, so please ensure that you pick your personal information, but of course you can talk and give the general, I am from Jamaica, blah blah blah, that type of thing. All right, we want this to be a very safe space. We don't want to have any problems. All right, cool. So continue your conversation. Wow, guys, can you hear me? Can you hear me? I'm not wearing my earphone. And I think if I should plug it in now, I'm going to be losing you. So just tell me if you can hear me. If you can't hear me, I'm not going to be using an earphone. All right, beautiful, 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 beautiful. All right, just where we want to be. All right, so pretty interesting, pretty interesting. Uh, have an awesome lineup for you this evening. I always like to make the Sunday, Friday evening very short. I do hope that we'll be able to get to that. Welcome to Mr. Wilson Live. You would have observed that we have changed the name of the show to make it very easy for you to find. So it's now Mr. Wilson Live. And you can find us, of course, on Google, or you could type in Mr. Wilson Live or CSEC Biology, the cover page, and you'll be able to find us as well on YouTube. Welcome to the show. We're streaming from Jamaica, and of course, we are live. The show comes to you every Wednesday, Friday, and Sunday at 5:05 p.m. It is probably one of the greatest Caribbean shows with some of the brightest learners across the Caribbean. I am pretty much the facilitator, but I pretty much learn more from those persons who partake in the session. If you have not yet subscribed, now might be a very good time for you to be a part of the show. In order to be a part of a live show, you need to hold a YouTube account, and of course, you can just come on over and join. It would be nice if you joined the family, as it's a family of intellect, and of course, we always like new members. Yeah, we have enough food to feed you, so don't worry about that. If you are in distant land, remember to like, share, and of course, call out someone to come and join the family. We're going to be here until about 7 this evening. We're going to be looking at coordination and control, and we're going to be going through the three reflex arts for the exam. And of course, this is just a part of coordination and control that we'll be doing this evening. We are going to continue this lesson on Sunday, where we're going to be looking at the brain, and we're also going to be looking at plants and, of course, hormonal control. At the end of that lesson, we are going to be looking at the comparison between the chemical system, which is, of course, hormones, versus the impulses, which is, of course, from the nervous system. And we're going to make that comparison, and then that should bring us to the end of coordination and control, or one might say irritability or sensitivity, depending on what text you're using, the name might change. But I'm very happy to have you this evening, and I have a long list of persons waiting on me. And as usual, you know, I have to say good evening to everyone. So let me just start it. Didi, good evening. Barnett, good evening. Macmillan, good evening. Jawawan, good evening. And of course, the list continues down and down and down. And they have been having a wonderful conversation. I think I'll have to take the time out to read it at the end of the class. Kevin McKenzie is with us. I might big up Kevin McKenzie. He did very well in his is it end of term exam. Big up yourself, Kevin. And then I see the Sosa, you are here as well. Good evening and welcome to the show. Remember, at any time, I'm seeing Edmond Mack. I am very happy to have you. It seems like you are new. I don't know that name, but welcome to the show. Powell, you are back. We haven't seen you for quite some time. Welcome back to the show. We are missing Tanisha. We are missing Otisha. Where are the Guyanese? Reflex, welcome to the show. So a number of persons are not here. The family is usually about 20, 25 persons on board, with about 150, 200 persons who are not usually on board, but they are watching, locked to the show, pretty committed, and of course, a part of the family, and we love you all. I am really disappointed. Why are you disappointed, Reflex? Tell me before we move on. Why are you disappointed? Let me hear that before we move into the show. Big family. Reflex, what went wrong? I was not following the chat. What is it that you're disappointed with or about? Rafiq. Is it Rafiq? Yes, no. I think we had a blind class the other day, and there are some letters I'm still not seeing good. I'm very sorry about that. I'm seeing something like FL. Oh, it's Rafiq. Oh, you don't like online classes. Do you want to tell us why? Do you want to tell us why? Was the conversation about online classes? Do you want me to partake in that, or do I jump into the lesson? All right, sir, I'm gonna be in an out class dealing with family issues. That's fine. Remember, you can hit the replay button at any time to see what went on in the show. I get distracted. Okay. I think Rafik is disappointed in doing bad in exam. Well, that is a good start. I like to tell students, when you don't do so well in an exam, that's fine. What is important is that you know where you are able to measure yourself. I did say some time ago that I have exam preparation, and it's a long list of stuff. I have actually started putting the video together, and I could just share some stuff with you before I move on, being that Rafik is not so happy. But I'm going to share with you some things that I have to come out in the video before I start the lesson, to see if we can allow or help Rafik to feel better. A part of the lesson in preparing, a part of what I have here for exam preparation, I have past papers. And I think I have some reasons why you should do past paper and when you should do past paper. It says here that you're supposed to start working past paper at least 4 months before the exam. And adequate, you should do about 5 to 10 years of past paper should be adequate. Even if you have not completed the syllabus, use the past paper and the textbook to, of course, help to answer the questions on the past paper. That should bring you very close to the one. The other point is that it is okay if you can't answer all the questions at start. So when you get started, I get distracted to create. Okay, when you find that you can't do a question and you use the textbook, of course, after some time it will get better, and you'll see as I go through. I won't tell you everything. I'm just giving you bits and pieces of a video to come out. Use your textbook and the internet to help you to answer those past paper questions that you can't answer. Don't go flustered that, oh, I can't do this exam because I can't even answer these, and this was last year exam. But you are not going to be doing last year exam. You are going to do this year exam or next year exam. So why are you worried about last year exam? The beauty about last year exam is that things might come from last year exam. And another thing, you get to do this exam without being able to fail. You can't do last year exam and fail. It has already passed. So you practice, practice, and become perfect. So when your exam come up, you'll be much better. Don't worry yourself, guys. So let us move on. Another thing I said in the document I am preparing, your teacher may also come in handy in helping you with paper. Persons from time to time, they send me questions on the channel, in the channel email, and once I see them, I will respond. Another thing is that past paper give you a true picture of what the exam will be like. So after you have started doing the past paper, 4 months I gave you, So month one, you start doing 5-year past paper, you're doing 5-year worth of past paper. And month one, you've done the past paper. All right, very good. Month one, you have done the past paper. Not so strong. Month two. Now, when you get into, remember 4 months. So we start the first, when you start, that you have 4 months. The first month is going to be month one, month two, month three, month four is that month that the exam will be at the end of that month. So when you reach month four, what you start doing now is to ensure by the end of month two, by the end of month three to month four, then you are going to start timing yourself for the exam. So when you go into the exam, you know exactly where you're going. All right, let me just continue very quickly. I'm not going to be giving you everything because the video is coming out soon. Another thing it says, it helps with gaining, it's help with gauging your responses. So you know very well how much you are going to need to write for a particular question because you did practice and you have a clear understanding as to what will be needed. All right, good afternoon. Good afternoon. If I don't answer, forgive me. As soon as I see, I will respond. Now, with the past paper, it also help you to zero in on specific topic. By now, I have a couple of HSB paper out there. I have 2015, 16, 17, 19, 2020. Now, if you have gone through all those papers, you would have picked up a trend. And you can say, based on this trend, CXC might change based on the number of questions I'm seeing changing within this 5-6 year. So I have a good understanding as to what will come and how they will change the paper. Remember, you are responsible for your learning. Mr. Wilson can help you, but it's like carrying a horse to the water. I really can't make the horse drink, but of course I can take the horse there. So what I'm saying, take charge of your learning. Take charge of your learning. The biggest competition you are going to have now is yourself. So start competing with yourself. What is it that I need to do? What is it that I can do? Set timelines and fail. Set timeline. You're getting up 6 o'clock in the morning and fail this morning. Get up 6:05 and then you are measuring yourself. Oh, I got up 6:20 this morning. All right, I'm going to try and see if I can get up 6:10 tomorrow morning. Try again and you might get up 6:18. Try again until you get to 6 o'clock. But keep trying, set those goals. Fail to reach them. So you are failing, failing, failing until you eventually reach. But remember, your goals should be smart. So ensure that you have timeline. Ensure that you have timeline. And let me tell you something. I soon tell you the rest of stuff. The lesson coming up, don't worry yourself. If you are out there and you have not yet locked in, like, share, and subscribe. I'm giving a little preview of a video I have coming out as to how to gauge and prepare for the exam for those persons who are running away. We are not running away from any exam now. We are going to take on the exam, big bad and bull and that type of thing. That is Jamaica talk type of thing. All right, good. So I was just about to say to you, for those persons who are going to subscribe now, it is all right to fool your teacher. Yeah, I have fooled my teachers. Yeah, it is all right to fool your parents. Yeah, I have fooled my parents. It is all right to fool your friends. Yeah, I have fooled my friends. But when you start fooling yourself, it means that you are mad. When you start fooling yourselves, it means that you are mad. So don't fool yourself. Set realistic goals and work to meet them. Don't tell yourself that I'm going to be having this exercise regime and you never get up. So when are you going to have the regime? Only in your head? Oh no, let's get back to the thing. So it said that it's going to help you to better understand the syllabus. So Mr. Wilson can give you all the notes in the world. I can come here and chat and blah, 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 blah. But you understand that the content is what it is. But when you get the real practice of the past paper, it brings to you a clearer understanding of what the syllabus intended for you to learn. So that is why you have to practice, practice, practice. And if you are one of those persons who follow the Bible, remember the Bible is saying, study to show thyself approved. Then I continue here by saying it will help you to know the content. So there are some persons you are not going to finish the syllabus because of COVID, because of your limitations, but just lock in on the past papers. Lock in on the past paper. Start play it like you're playing chess, domino, ludi, draft. I don't know what you're playing in your other Caribbean island. Start making the past paper being your game. Damn, I answered that question. I didn't know I'd be able to get this. You can't find the answer in your textbook? Go to YouTube, go to Google, look at different videos. Start making learning be fun. Start competing with yourself because you have nobody else to compete with. You can't always reach Mr. Wilson. Good, I soon read that, De Souza. Let me continue here. It will help you to predict trend. It will give you more meaning to the content learned. It will also help you to develop a fun way of remembering the content. It says it will build your confidence as you practice and become better at the subject. It will pull you closer to persons with similar interests. You realize that everybody in the room here, they have similar interests. They are not here to listen to IT that I will talk every now and then. They are here to listen to biology and HSB. So that is what past papers will do. But while I looked at past paper in preparing for exams, I also looked at extra classes. I also look at extra classes. Whether we like it or not, there are many teachers and teachers are different. A teacher might teach me and I get a 1. And the same teacher teach you and you get U. Because there's just something that you're just not connecting with. There's just something that you're not connected with. So I am very happy when I came in this evening and I realized that there was a conversation in the class before I came in. I really don't know what you guys were talking about because I didn't pry in your business. All right, let me see. Sir, yesterday I was at class doing a little exam. The question on the paper was climbing, was it climbing up a mountain? Climbing up a mountain, a group of hiker finds that breathing. Oh, I see the question all the while. The Azteca thing. We talk about the Azteca. When I taught respiration, I did this. Yes, because as the altitude go up, that type oxygen level. Go back to my video on respiration and you see it becomes difficult. This is most likely because I'm not too sure what the responses were, but I did cover this at length in that respiration video. I spoke about the oxygen chamber. I spoke about going to the Azteca 2 at least 2 weeks before the football game. I did look at this particular question. Air has less oxygen, all right? And you are using a lot of energy. Outside of the energy, it's not really an energy question. It's more about oxygen being in the air. It's not, it's the altitude. And I think there's a graph for that, and I did do the graph and all of that. I don't remember. If I didn't, I'll do it with you sometime. All right, so just let me finish this and get to the lessons. We're looking at sensitivity and coordination today, but let me tell you something, man. It is like you're at driving class, and your teacher is telling you how to drive, but you have never gone into a vehicle, right? You've never gone into a vehicle, but the teacher is teaching you to drive. So here I am going through the notes with you and a little past paper here and there every now and then. I have to tell you how to really get prepared for this thing, because there's what we call exam tactics. You have to master exam tactics in order to get the 1. I'm confident that a lot of you will be getting 1. All right, so extra classes. These are my views, and these are what I'm putting out in the video. These are classes outside of your timetable classes. So you have some classes that your timetable for. If you are at school, you have some, if you are going at even class, that could also be an extra class. In some cases, that is the class for persons. Like this class is pretty much an extra class. They enhance learning. Extra classes enhance learning because in this learning community, Moore might say something, the Sosa might say something, DD might say something that my Ed just doesn't have that information at the time. And of course, somebody else can pitch in and that type of thing. And you come to class early and you can have a conversation. They give another perspective of the content, extra classes. They provide a space where you can share with others who have similar interests. Not because you're in the class, whatever class you're in at school, and you're all in the science class, it means that everybody wants to do biology. Some persons just want to do chemistry and physics. But when you're in a biology space that you decided that you wanted to be, then everybody will have similar interests. They will allow for more practice time, extra classes. They help those who are slower. So those persons who are not so fast, the extra class will start to push them a little more. And those who are fast, they will also help those persons to perfect the skill. And we are looking at extra classes. They allow for a change in learning environment. All right. So you are used to your teacher wherever. None of you have ever seen me. Probably for Rafiq and Mackenzie, they have seen me. But outside of these two persons, nobody else here have ever seen me. But it's a different thing. Sometimes I come and I am all starch, Mr. Wilson. And another time I have a little humor here and there. And persons might laugh. Sometimes I listen to you and I laugh. And sometimes I can't see the letters well on the screen and you laugh. But we laugh every now and then. It helps to reduce stress that are associated with more formal learning. So you are in my class, I ask you a couple questions here and there and that type of a thing, but you're not so stressed being here. You can drop your shoulder and that type of thing and learn and enjoy. You can see other persons and look how other persons enjoy. So there are a lot of persons here who fail to learn. And when I talk fail to learn, it doesn't mean that they don't learn. What it means is that they fail, they try again and they learn, and they might fail, they try again and they learn, but they are not failures. What they do, they continue. Now, when I look at Microsoft, if you know about Microsoft, when Microsoft sent out their first set of program, they went again and they did something else. They went again and they did something else. They went again and then you have different series. I remember when Millennium came out, it was a disaster, I think. And then they came out with some patch and then they fix it and fix it and fix it and fix it until they became perfect. Now, if these big companies can continue to fix themselves to become perfect, why are you so hard on yourself in doing a past paper, getting a question wrong, do the question again using your textbook or the internet or a teacher help, and of course, becoming better? Don't be afraid to fail before the exam. Don't be afraid to fail before the exam. Try the past paper. If you don't get it, go to the textbook, go to the internet, go to your teacher, because you have a dream. I am going to ace this exam and I'm going to use all the resources I have available. All right, so I have here the learning setting. As a learner, play an important role in the process. I'm not going to be giving you anything else from that video that will come out later. It's about preparing for exams, and of course, I think it is called. Let me tell you, I think it's called a game changer. Thank you. I think it's called a game changer. Sorry about that. That's what I answered from my past paper, and he says I'm incorrect. He said that you are incorrect. Which other past paper is that? Which past paper? Tell me and let me go and look at it. Tell me, let me go and look at it, and also give me the answer that your teacher would have proposed. Just let me scroll up and get that bit. All right, so A, oxygen, and you are using a lot. Thank you, sir. I really learned a lot from your online classes. Thank you very much. Sorry for being late, sir. Same. That's what I answered from your past paper, and he says I'm incorrect. I got exam nerve and forget lol. Thanks, sir. Really, all right. All right, my pleasure. Rafi, you think that short. We all have short-term memory. To remember anything, you have to practice, practice, practice. You can make flashcards. All right, all right. So the 2018 past paper. Do you remember what question it was? Do you remember what question it was? And what is your teacher's? You chose A. And what is it that your teacher chose? Good evening. What is it that your teacher chose? Oh, so it was 2018 May or January, somebody's asking. I think it's May, June I don't remember. Just tell me what is it that your teacher chose. We can look at it and see what went wrong, if something went wrong. And if we stand by what we have, they will definitely tell you that we stand by the answer. If there's something to be changed, we'll let you know and we will put it in the description. But tell us what it is that your teacher chose and we're going to look at it. And of course, we will provide you with the evidence. 2018? I don't have 2018. No, if it is 2018, it's not from me. I don't have a 2018 past paper out. I'm sorry, I don't have a 2018 past paper. It's the only year, I remember when I started out, I did say 2015, 16, 17, 19, and 20. We don't have a 2018. Are you sure that it is 2018? If it's 2018, it's not our past paper. We don't have a 2018 past paper out. I'm sorry, we don't have a 2018. If it's a 2018 paper, it's not ours. So please check again. But I know that I've seen a question like that. But if it's 2018, like I continue to say, it is not our paper. Question 16. No, I don't have a 2018 out. I'm very sorry. All right, so it's question 16. And he said that the answer is C. All right, so you sure which paper it is? Are you sure that it is 2018? Yes, no. But sir, I saw that same question on the 2016 paper as well, and that the same answer I got while watching yours. Okay, let me look at 2016, because one of the things you have to be very careful with, you have to look at what the response was and not the letter. So we are going to be looking at 2016 paper, and we will provide you with some information in the comments below that. I am trying to pull the paper to see if we can look at that, and we will put it below the paper should there be a need for any correction. All right, so that's going to be the end of that for that now, but we will do the check and of course provide feedback. I'm going to double check. I found the question. It's May, June 2018, question 16. Okay, it's not my paper, but I will look at that same question in 2016 to see what the response was. I don't know what it was on 2018. We don't have that paper. All right. All right. So again, good evening, and let's hop right into the show. A lot we have said earlier, but we want to go ahead with the show for those persons who are going to be leaving us shortly. Otherwise, oh, it's on 2015 paper as well. Oh, so it's a question that is popular on the paper. All right, so we're going to look at it, 2015. And it is the respiration question. All right, so here we go. So we're looking at coordination and control. And coordination and control, before we get into coordination and control, it's very important for us to understand what is coordination versus what is control. So my first question to you is going to be, What is coordination? What is coordination? So we want to look at what is coordination. We want to look at what is control, and of course, why. Why is it that coordination and control is important? Yes, the question will repeat, but sometimes it repeats and it's not pretty much to the same letter assigned. We are not here saying that we are wrong or we are right. We are going to look at the question and we will revisit the question. Like I have said, we will put the amendment, should there be any amendment, in the comments and the description. So when you look at the papers, you will look to just check there to see if we have anything, any amendment. All right, so we're getting the response now. The class has started. The response to stimulus, not sure. Working together for movement. Jawawan, the organization of different elements of a complex body or activity so as to enable them to work together effectively. I think you should cite where you got this information from. It's look a little Googlish, so you need to say whose information it is because we really don't want to claim right to other person's information. All right, good. So coordination, simply put, is to organize parts to work together. When you coordinate something, you are organizing different parts in order for them to work together, and not only work together, but to work together effectively, and one might say efficiently. That is coordination. Now, control is pretty much to set boundaries. So in coordination, you make the things work together. But then you are going to set boundaries with control. Now, when you set boundaries, you are actually regulating activities. Now, this is what the nervous system does. Now, why is it important for us to have coordination and control? Now, one, for efficient use of energy. To coordinate and control anything, it is helping you to save energy. The other thing that it does is, of course, to help you to make effective use of time. Another thing that it does is to ensure that things are done in a timely manner. It ensures that things are done in a timely manner. That's three. The fourth thing that happens here is that it ensures that we stay alive. So coordination and control, it ensures that we stay alive. And we're going to be proving that as we go through the lesson and of course, explore different things. Now, you can recall many a times you're crossing the road and there's something coming and you pretty much have to run out of the road. Can you imagine if you had nothing to coordinate or control you and you stood there and you had to figure out whether you're going to be moving your hand first, your neck first, the feet first, that type of thing, probably you would have been dead by now. Or can you think about one day when you got burned by the stove or something like that and you had no coordination and no control? Do you know what would have happened? Are you using the knife and you have no coordination and no control? Probably you just cut off your hand or something like that. So you see that coordination and control is very, very important. And as DD put it, if there's no coordination or control, or coordination and control, we are definitely going to have chaos. Now, the question will be asked, who or what coordinates? Now, I'm going to ask you, who is responsible for coordination and control in your country or your island? Tell me in the chat. Who is responsible for coordination or control in your island? All right, I'm coming. I'm just looking for the question. All right, I'm looking at the question, the 2015 paper, 2016 paper, and it is definitely not where you say it is. but of course we will continue to look. If you can tell me where on which paper we have it, I'll be able to correct it very, very quickly if there's need for correction. All right, so Didi is saying that in Jamaica, the prime minister coordinates what happens in the country. Some person say Didi is saying police as well. I must be extremely late. Government, more is saying that the government does the coordination, and of course, basically the government, yes. So it's 2015 question 16. 2015 question 16. All right, beautiful. All right. So we're now trying to find out who does the coordination in your country. All right, good. So the government is always going to be responsible for the coordination of your island or your country. And of course, the government is usually headed by someone, right? However, it doesn't take that individual alone to coordinate the country. It is going to take the entire government, the different ministers and so on, to ensure that the country operates and run well and is able to trade with other countries. Now, what is responsible for coordination and control in the body? We know that it is the government that coordinates the country, coordinate and control the country, and not the prime minister. He's just an element of government or one person within the government. So, what is responsible for coordination and control in your body? All right, give me that in the chat. ah, ah, that was uh, I am sorry. I looked at the question at a glance just now, and I will stick with my answer, and I will provide the proof. All right. I am going to be explaining sometime in this show why we went with that. I'm going to be asking my assistant to just pull it from respiration, and I might just read the content to you directly from the textbook. And not only that, I will show you how the exam paper is structured. If you look at that particular question, you will realize that there's a respiration question above it. Right? So it's a set of respiration question coming down, and tired is not the thing. I'm going to help you to interpret that question. So we might have to revisit it as teachers. It's multiple choice and it lends itself to that. So don't go bash your teacher and don't go bashing Mr. Wilson. We'll find a common ground in order to answer the question. All right? So I'm not here attacking your teacher. All right? No respect your teacher. Big him up for me just the same. All right? So let me continue with this lesson here. All right. I don't even have that textbook that is explicitly stated in with the oxygen chamber. All right, so government, ministerial, local government. All right, we're just going to stick with the show now. All right, central nervous system, nervous system. All right, central nervous system is a big word. Careful, look at these things. The nervous system, central nervous system, peripheral nervous system. All right, like up the, all right, big up the thing. Receptors and all right, I get in a whole lot of responses. And when I get so many different type of responses, I don't try to propagate it. I just want to stem it. All right, so I'm going to be looking at the bad responses and I'm going to be looking at the good responses. All right, so I started out and I gave you a clue. I said to you that the prime minister, which would have been the brain, is not the person responsible for coordination and control in the country. It is the government, the ministers, whatever, everybody make it up. The prime minister might be a key figure, but it's everybody. Now, the peripheral nervous system speaks to all of those nerve endings and things, nerve coming off the spinal cord. Now, the central nervous system, CNS, not only the spinal cord, forgive me there. Peripheral nervous system, I'm going to be doing it shortly. I think I'm moving too fast. CNS, central nervous system, speaks to the brain and the spinal cord. All right? And then you have the peripheral nervous system, which has the other attachments to it. And I will get into it. Now, what is responsible for coordination and control is the nervous system. What's responsible for coordination and control? It is the nervous system. All right? Not the peripheral, not the central nervous system. Those are parts, but they are not the coordination and control center. It's pretty much more than that. All right, I'm going to be going through all those things that make up the central nervous system, all those things that make up the nervous system, and that might help you to better understand why it's not the brain, why it's not CNS, why it's not the peripheral nervous system. All right, so let us look at it. I'm going to be breaking down some things. We want to start with some key terms. Slow it down now for me. Yes, the brain's apart. We want to start with some key terms. I feel like I'm a little over the place, so I want to streamline. Sorry, I want to streamline it now. So the nervous system is responsible for coordination and control of activities in the body. Now, the nervous system is a really big thing, a vast thing, right? But before we get into that and what it is made of, I want us to look at some key terms that as I get deeper into the lesson, you will, of course, follow as I use these terms. Now, the first thing I want to look at is stimulus. Tell me in the chat, what is a stimulus? In the chat, what's a stimulus? And then after we would have looked at the stimulus for those persons who are going pretty fast, we are going to look at a receptor. We are going to look at, of course, effector. We want to look at nerves versus neuron. So while you look for stimulus, I will say a receptor is that which detects a change. A receptor is that which detects a change. Now tell me, what is a stimulus? Sir, changes in the organism's environment. So a stimulus is pretty much a change in the environment. And when we talk about a change in the environment, we are not talking about a bulldozer digging down somewhere. That is, of course, a change in the environment. We're not talking just simply about it started raining today or it was sunny today. We're not talking about that. So I want you to look at me and I want you to identify the change in the environment. What was the change in the environment just now? Type it in the chat for me. What was the change in the environment? I did something a while ago. What was the change in the environment? And I'm going to do something else. I closed my eyes. So that was a change in the environment, and that was something that you detected. What was the other thing I did? You weren't paying attention. All right. What else did I do after closing my eyes? I waved my hand. That's a change in the environment. And if I were supposed to turn my head like that or turn my head like that or whatever I do that is outside of the norm is a change in the environment. And if I were supposed to sit here and you would have heard the yengers riding by, that's a change in the environment. And of course, it is picked up by something. We're going to get there, right? And if, of course, I got a sweet and I was eating the sweet, and that's a change in the environment. Right? So a change in the environment is, of course, detected by your 5 senses. And please do not understand the change in environment to mean that it starts raining today, or it is sunny over today, or it is overcast. Those are actual change in environment. But when we talk about changes, we are talking about everything. Everything It moved from norm. I was seated here and I move over there. It's a change in the environment. I turn my head like that, it's a change in the environment. I start talking, change in the environment. I stop talking, change in the environment. All right? So we have to be cognizant of that, that a stimulus is simply a change in the environment. And we respond to them because we have things that we refer to as receptors that are able to detect the changes in the environment. So your receptor is going to pick up the change in the environment. So there are some receptors, and we refer to, the big thing you will remember them as are the sense organs, right? And these sense organs, they are able to, of course, detect changes in the environment. You'll recall that the eye will detect light. You'll recall that the ears will detect sound. The nostril will detect scent. The mouth will detect taste. And of course, the skin will detect temperature, pressure, pain, that type of thing. We're going to look at that again. I hope I didn't go too fast just now. Huh? The mouth contains the tongue. Yeah, the tongue is in the mouth. I didn't look at the specifics. All right. So when I looked at the eye, I could have said receptor and cones. I'm they're just saying it's a tongue. Yeah, it's the tongue, but I looked at the ears and I looked at the nostril. I didn't look at the olfactory cell and all of that. Right. I just look at where it is. All right. So and I looked at the eye. I didn't look at the rods and the cones. So I know that there are other persons who are saying that it is the tongue. But if you are going to say it is the tongue, which is of course correct, you must say the rods and the cone. That is of course correct. All right, so we're going to be looking at that in more detail as we move along. So we spoke about the stimulus, which is of course a change in the environment. We spoke about receptors, and we're saying that the receptor are those things that detect the change in the environment. And we said that the sense organs are responsible for detecting the change in the environment. Of course, there are many modifications to the sense organs, and we will look at that as we move along. Then, having picked up a change in the environment, then we need to do something. And we are going to have, I'm not too sure why we said quiet there. We are going to have effectors, and the effectors are going to bring about a change for you. That's how you are going to respond. The receptors are going to respond. And the effectors are going to be your muscles and, of course, your glands. And we're going to be looking at that. They are going to be your muscle and your gland. Hunt, you're saying something quite. I'm not too sure what you're saying there. Oh, wave. Okay, okay. You're responding. We have a log there. He's responding to what I said earlier. All right, beautiful. So we look at stimulus, receptor, effector. Now we want to talk about nerves and neuron. What makes the difference between nerves and neuron? So it's pretty much a bundle of neuron that would make up a nerves. So I'm going to tell you a little bit about nerves and neuron. I don't have what I usually use to teach it, but I can tell you. I don't know how many persons know what is called an Ethernet cable, that blue cable or white cable or orange or yellow cable that you plug in the back of your laptop or computer to get internet. Now, if you were supposed to cut that wire and look on the inside, you would observe that there are many other small wires. Now, each of those small wire, not really cable wire from outside, the Ethernet cable on the inside, not the coaxial that is coming from outside, the one that is inside that you plug in. I think I could get one and show you. Just give me a second, because it seems like if we don't know. Jason had a Ethernet cable. Beautiful. All right. Sorry about that. All right. So this one with I don't know if this is RJ45 or RJ11. So you are seeing this jack here, and if you look inside of it, you are seeing a lot of colors, and those are little wires. So I'm saying if you are looking at this long process here, this that we're looking at would have been the nerves. Now inside of this, there are some smaller wires. You are seeing them up here. There are some smaller wires inside of this. Those would have been the neuron. So the neuron is a single cell, while the nerve is a bundle of cell that is, of course, wrapped in a sheet, and it appears to be a white thread-like structure. All right, is anybody there? Amoy, what does that mean? With different color, yes. So this has some different color. All right, beautiful. So we have looked at some stuff. I keep saying the same thing over and over. Just to concretize, we have looked at the stimulus, and we have said that the stimulus is a change in the environment, and we looked at many changes. We have looked at the receptor, and we have looked at some organs that are responsible for detecting the change in the environment. We said that the receptors, they are very important in detecting the change. And then we are saying that the effectors are going to help you to respond to these changes. And you're going to see it as we go deeper into the lesson. Then we looked at the difference between the nerves and, of course, the neuron, where we said that the neuron is a single cell, while the nerve is, of course, a bundle of cells. Now, let us look at the sense organs very, very quickly. Now, the sense organ, we're going to be looking at the eyes, and of course, the eyes are responsible for detecting various light intensity and, of course, color. We can relate to the cells that are responsible for that because we just looked at the eyes, which are, of course, the rods and the cones. Then we can look at the ears. And the ears, they are responsible for detecting sound. You're hearing, Mr. Wilson, all because of your ears. But that's not the only thing that your ears will do. They're also responsible for helping you with balancing. All right, so that you don't topple over. Unfortunate, if you can't manage this graphic example that I'm going to be giving, just step away from your computer a little bit. I'm going to be giving an example now. It's a real life example. Unfortunate it is, but I'm going to be sharing it with you. And I do hope that no one try to practice this. All right, so I have witnessed an individual got some ear injury. I won't tell you how or why, right? And what we observed that when they got this ear injury, they were not able to stand upright, right? The person walked and they kept falling, they were falling over. Sorry, they were falling over as they walked. We had to hold the person up. Now, all that happened because of the magnitude of the damage in the ears. So I am certain that the ears is also very, very important in balancing. Now, another thing we look at the skin. And the skin is another sense organ there that is responsible for detecting pressure, as in touch. It also determine or detect pain if you are feeling pain like if somebody step on your toe or something like that. Not if you're feeling belly pain. That's a different thing. All right. And of course, temperature. All right. All right, good. And then we have the nose or the nostrils, and they are responsible for detecting, like we said, scent, the olfactory cell. And we have the mouth with, of course, the tongue, and the tongue is responsible for tasting. And you know that we're able to taste sweet, sour, salt, bitter, and of course, there are different degrees in between. All right, that's what happened when we spin and why we lose balance. Yes, because the chemical there in the ears or the liquid there. Right, but very good. All right, so we move right along. Those were the sense organs. And of course, I know that I might be going a little fast for some persons, but if there's something that you don't understand, just slow me down and let us have it resolved. So we are going to look at coordination. Now, coordination, as we started out, looks at what happens between the receptor and, of course, the effector. And of course, it get done. Whatever happens there will get done by pretty much the impulses that are sent along the nerves or hormone that is sent in the blood. So now you see we're coming up with these fancy words that we had to learn earlier: receptor, effector, nerves. And we didn't look at hormone, but hormones are simple chemical messengers. And we're going to be looking at that in a class by itself. Now, the nervous system, that's where we started out. I will look at coordination, what needs to be coordinated, whatever happens between the receptor and the effector, they need to be coordinated, and the coordination is it's brought about pretty much by nerve impulses or hormones that are sent in the blood. So remember, nerve impulse is going to travel along the nerves, while the hormone is going to travel in the blood, and the hormones are actually chemical messengers. Now, the nervous system, that is how we started out. And the nervous system is made up of the brain, the nerves, the sense organs that we made mention of earlier, hormones, and of course, all these work together to ensure that coordination takes place between the effector and the receptor. All right? So the next question is, and you can tell me in the chat from your research, what is the nervous system? So I just told you the parts of the nervous system. But what is the nervous system? Because we're saying that coordination and control is a responsibility of the nervous system and not necessarily the brain. The brain might be the prime minister, as you put it, but of course, it takes more than the prime minister to run the country. It takes more than the brain to run the body. It's going to take the brain, it's going to take the nerve, it's going to take sense organs and hormones in order to coordinate and control the activities of the body. So tell me in the chat there, what is the nervous system? Now, a lot of persons, when I asked the question earlier, they made mention of CNS, the central nervous system. They mention of PNS, the peripheral nervous system. Now, the central nervous system, as I said earlier, is made up of the brain, which is in the cranium, protected by the skull, and the spinal cord, that most persons like to call the tail of the brain. Get that? That's central nervous system. Then we have PNS, which is the peripheral nervous system. And the peripheral nervous system is made up of the cranial nerves. Now, the cranial nerves are those nerves that are attached to all of these parts up here up on the cranium. And we're talking about nerves that are attached to the eyes, the ears, the nose, the mouth, etc. Those are cranial nerves. So those are a part of the PNS, a collection of nerves, neuron, that transmit impulses throughout the body. And that is just still a part of what the nervous system is, because the nervous system must have the brain as a part. But well done. We need to modify that definition. A little more is needed there. Now, another part of the peripheral nervous system is, of course, the spinal nerves. The spinal nerves. And the spinal nerves, I like to say those nerves that come anywhere from here downward, that comes pretty much off the spinal. They might go to the hand, they might go to the organs. And of course, like I just said, they are coming from the spinal cord. So if you were supposed to look at the body in its framework, you'd see like this, the spine coming down, and then you'd see the cords coming off, the nerves coming off the spine there, and we refer to those as, of course, the spinal nerve. Is a major controlling regulatory and communication system in the body. That says a lot. It doesn't give any example, but pretty much that is what it is. The nervous system is, of course, as these two persons rightfully put it, it is, of course, controlled by the brain, but it is made up of several other parts. Thank you very much. All right. So we have just looked at central nervous system. What is the central nervous system? It's made up of what again? Tell me in the chat there. What are parts of the central nervous system? CNS as it is called. There are some persons who said that they were gazing. So tell me now, parts of the central nervous system, what are they? Right? And as soon as you do that, then you are going to tell me again, what are the parts of the peripheral nervous system, or PNS? So you are going to write CNS, and then you tell me the parts. All right? So brain and spinal cord, those are the parts of CNS. Brain and spinal cord, those are the parts of CNS. All right? Nervous system, the main coordinating system, which is divided into the central nervous system, brain, spinal cord, nerve, and peripheral nervous system. Pretty much, this covers a whole lot, a little more comprehensive. All right, CNS, brain, spinal cord, central nervous system, all right, cranial nerves, spinal nerves, Java, one way, I'm not too sure where you're going with that. Just let us slow down a bit. Oh, you're at PNS. All right, so for PNS, it's going to be the cranial nerves and the spinal nerves. For PNS, all right, PNS, cranial nerves and spinal nerves. Now, I want you now to give me, of course, some examples of where we would find cranial nerves connected to what or where. Where would the cranial nerves be connected? Give me some examples of places that they would be connected. Examples of places where the cranial nerves would be connected. Cranial nerves would be connected to the brain. All right, give me some other organs that it would be connected to. Other organs outside of the brain. I gave you a list of some. And Jawawan, why I'm asking for that, because I want you to have an appreciation of cranial and, of course, spinal nerves, so that when we look at cranial reflex versus spinal reflex, you have an appreciation of what and where we are looking at. All right? So when I ask, give me an example of cranial nerves, I realize that there are some persons who still don't remember where they're attached to. We spoke about the eye, we spoke about the nose, we spoke about the mouth. We said that the attachment here, they are, of course, associated with the cranial nerves. And then the spinal nerves, remember we said that those are coming from the spine and they go to the hand and the organs and all of those things that is below pretty much the head. All right? Good. We want to remember that. We don't want to leave that anywhere. All right? So there we have a change in the environment. The bike passing by, you would have heard that loud noise. Let's go again. Now we're going to be moving on to something that ties up this thing a little tidier, makes it a little nicer. We're going to be looking at the types of nerve cells. Now, I am sure that you know the types of nerve cells. So I want you to tell me very quickly in the chat, what are the types of nerve cells that you know? And might I say, there are 3 types that we're looking at. All right, so tell me very quickly in the chat, 3 types of nerve cells that you know, you read about, you've seen in a book, you watched on a video. 3 types of nerve cells, share with us. All right, so Bertram is saying sensory. You can type all 3 at the same time, just use a comma. So Bertram is saying sensory. Bertram is saying motor. Bertram is saying reflex. Interesting. All right. Bertram is saying relay. Okay, it should be relay and not reflex. I see. All right. Anybody else? Anybody else? Sensory, motor, neurotransmitters. Not too sure. Relay, motor, sensory, motor, relay, sensory, motor. All right, come on, guys. Feel forward. We're looking at the types of nerve cells, motor, sensory, mixed. All right. I've seen a lot of things. Guys, remember, I'm going to ask you questions, Sorry, so if there's something that I'm not too clear where your brain space is, I'm definitely going to ask you something about it. So I'm going to be asking Jawawan about neurotransmitter. What is your understanding of neurotransmitter? Sorry, mix, sensory, and motor. Okay, a lot said there. Jawawan, when you put your thoughts together, if you want to share neurotransmitter, would love to hear. Let me correct that. Okay, so the 3 types of nerve cells that we're going to be looking at is, of course, going to be those that were popularly mentioned here. And they are motor neuron, sensory neuron, and relay neuron. Just let me give you some whole lot of names for the relay neuron. Now, the relay neuron is the same one that they call the mix. The relay neuron is the same one they call intermediate neuron. The relay neuron is the same one they call connector neuron. The relay neuron, connector, intermediate, and of course, mix. Okay, not a bother. Now, let us look at what they do and what they look like. Now, like you have been so nice a while ago, I'm going to be starting it, and I'm going to be starting it so that you can follow in a sequence. So tell me, what is the function of the sensory neuron? What's the function of the sensory neuron? Everyone, type in the chat there for me. What is the function of the sensory neuron? I like where the lesson is going. What's the function of the sensory neuron? Function of a sensory neuron. All right, just type in the chat there for me. Kevin, please revisit your answer. Kevin, please revisit your answer. All right, Bertram has an answer there. Guys, please submit the answers. I am looking, I'm listening. Forgive me if you see me looking over here. I want to find something for somebody, but I am with you. Don't worry too seriously. I have this book that has this thing so clearly outlined in it. I'd love to have it. I would have loved to have it to help these guys who ask that question. But I'm going to be giving them a textbook answer for it. Never mind, I'm going to be giving you a textbook answer, if not now, later. All right, for that same question that you spoke about. I am prepared to argue with your teacher. That's fine. Your teacher could write me by email, and we could talk more about it so we can reach a common ground. All right, so let me see what's happening here. So sensory carry impulses from receptor to CNS. That's Bertram. Macmillan, to carry impulses from receptor to central nervous system. More sensory neurons carry impulses to CNS. And of course, Mackenzie, Bad, they transmit impulses. Mackenzie, please revisit your answer. Mackenzie, please revisit your answer. Jawawan conduct incoming impulses from sense organ to the CNS. It's very important that we understand that, right? It's very important that we understand where the message is going. All right. So I would have, well, we shouldn't. Based on what Mackenzie did just now, he would have smacked himself on the hand, right? And that information, it is picked up, right? So it's picked up by the receptor, and it will be taken now by the sensory neuron. So, all right, something hot, the receptor pick it up, sensory neuron take the information and send the information, right? So after the receptor pick up whatever the change in the environment is, that stimulus, then it is a sensory neuron that is going to take that information from the receptor and it's going to send it now into CNS. Beautiful. Let me see what's happening over here. All right. Conduct in, all right, send signal to the brain. Sir, I'm just joining. All right, that's fine. I'm happy to have you. We are happy to have you. All right, beautiful. So we're going to be looking at the sensory neuron. And when I planned this evening lesson, I said that it was going to be a practical class. That is why I have so much energy, because I'm all in practical. At the end of this class, I want you to remember just about everything. All right, so I'm going to pause the lesson because it's practical. I'm going to pause the lesson. You're going to learn though. And I'm going to go back and come back and go back and come back because I want you to learn. All right, so it's like I'm going to be shuffling the deck for you to learn. All right, so the brain and the spinal cord makes up the peripheral nervous system, right? Yes or no is fine. That's your response. Yes or no? The brain and the spinal cord make up the peripheral nervous system. True or false? Yes or no? Tell me in the chat. Am I correct? Am I correct? Okay. So Bertram is saying yes. Mackenzie is saying no. Bertram is saying no. So the brain and the spinal cord, they make up the peripheral nervous system. That's PNS. Am I correct? Yes or no? All right, a lot of persons saying no. They're saying no, and some persons are not sure. So they are not responding. But I think you should respond. I think you should respond. It's fine if you respond and it's wrong. All right. A lot of persons, they are not going with me. They are saying that you're going to take this lonely journey by yourself, but you're not correct. So I assume then that the brain and the spinal cord must then be a part of the central nervous system, right? Yes or no? So the brain and the spinal cord is a part of the central nervous system. Yes or no? Yes, yes, yes. All right. So a lot of persons are with me now. Beautiful, beautiful. So I am going to be touching some part of my body now, and you are going to tell me whether these are connected to a cranial nerves or a spinal nerves. So here we go. I'm going to be touching my hand. Is it connected to cranial or spinal? My hand. Is it connected to cranial or spinal nerves? Cranial or spinal? My hand. Tell me there in the chat. Is my hand connected to cranial or spinal? One person answered and the others are not too sure. So is my hand connected to cranial or spinal? Oh my. 3 persons and the others, they are not sure. Why wouldn't you be sure? Try. Fail forward. All right, so there are 4 persons and the others are saying that I am not even going to try this one. It's too difficult. This is a CXC exam and I'm not going to fail. Mackenzie is saying, of course, it is spinal. So my hand, is it connected to cranial or spinal nerves? All right, 1 to go. Anybody else want to answer? All right, beautiful. So it is a part of the spinal nerves. Let me go on down. What about my legs? Are they connected to cranial or spinal nerves? My legs, are they connected to cranial or spinal nerves? Sure, you can get that person outside to turn on that music for me or something. It's going to affect my feed. If somebody passing with that music or something, it's like disturbing, and you know that we're going to get flagged for that music. Next door. Where is next door? You can just ask them to turn it down. Tell them I'm streaming. They will. They will. All right. All right. Sorry about that, guys. I'm getting some music over there. And once we get music like that in the background, YouTube is going to flag the video for copyright. And we are not playing the video, but we can hear it in the distance. All right. So good. So the legs are, of course, spinal nerves. They are connected to spinal nerves. So too are the hands. And if I were supposed to ask you about the organs, they too are connected to spinal nerves. So I think we're doing well. What about my eyes? What are they connected to? Cranial or spinal nerves? Cranial or spinal nerves? My eyes, are they connected to cranial or spinal nerves? Are you with me? My eyes, are they connected to cranial or spinal nerves? Cranial, cranial. What about my ears? Cranial or spinal? Cranial or spinal? Cranial, cranial. All right, beautiful, 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 beautiful. Give yourself a round of applause. You did well just now. So now we are going back to where we're coming from. Beautiful, beautiful. We are going back to where we're coming from. Just now we spoke about types of nerves. We spoke about sensory neuron, we spoke about motor neuron, and we also spoke about relay connector, as it is called, or intermediate or mixed neuron. We spoke about it. It's actually 3. All right. So we said, we established quite nicely that the sensory neuron is taking that message from the receptor and it is taking it into CNS. Usually when I teach at school and persons can't get it, we usually get the marker and we draw arrow on the skin to show that it is going into CNS. All right, so you see an arrow there. So the receptor pick up the information, then the sensory neuron will take it into CNS. But what does it look like if we were supposed to look at it? Now, the sensory neuron, unlike the other neuron, it has a cell body that is not at the end. So the cell body is somewhere along the long process. All right. In your books, it might appear to be somewhat close to the middle, but it is along that process, right? It's not at the end. No, so always remember we're going to need this information when we get on over to the reflex arc, that the sensory neuron is going to take the information from the receptor, and the receptor pretty much detect the change in the environment, and it is going to take this information into CNS. Beautiful. So now we are going to move on and we're going to look at the relay neuron. Now the relay neuron is the smallest of the 3. I hope you're following in your text. It is the smallest of the 3, and they conduct impulses from the sensory neuron to the motor neuron. And they are just some very small cells that is found pretty much in the CNS. All right? And it's very important for you to follow that. So they are usually very, very small. We're going to be looking at the structure of the nerve cell, but just give me a minute and let us establish what they look like before we get into pretty much the structure itself. Then we have the motor neuron. Now, if you gave me some information and you say, Jawawan gave me some information and she said, take this information over to Macmillan. Ask Macmillan if he enjoyed class today. Then naturally, Jawawan is expecting a response. So I would have taken the information over to Macmillan, and of course, then Jawawan needs a response. So the fact that the sensory neuron took the information into CNS, then something needs to be done. So what is going to happen is now that it's going to go to in some cases, let me say in some cases, because I don't want you to fall on your face when we get round to the back of reflex arc, it's going to get into CNS, depending on the case or the type of reflex, if it's a reflex there, and then it's going to get into the connector neuron, then it goes to the motor neuron, and then the motor neuron will now send information to the effector. Now the effectors are going to be muscle and gland. Simply put, this is my bottle of water, and it is hot water. Hot water. And for some unknown reason, I happen to touch this. Sensory neuron will pick up the receptors will pick up the temperature. It is too high. And then this information will be sent along what? The receptor pick up the information. What will take the information into CNS? Tell me in the chat there. So receptor pick up the information. Tell me the pathway that it will travel. Tell me the pathway that it will travel until it stops, until everything finish. How much you can recall? So the processes. Tell me everything. Explain the entire pathway to me. Don't explain it. Just list them. Give me a timeline. This is happening. That happens. That happens. It goes there. It goes there. That type of thing. All right? No, it's much longer than that. No, it's much longer than that. So you have to tell me now that it goes from, all right, receptor, sensory neuron, relay neuron, motor neuron, and what happens after motor neuron? What happens after motor neuron? This is a very good attempt, more. Very good. What happens after motor neuron? What happened? A response. So the response here is that the motor neuron took the message to the effector. In this case, it is a muscle, and the muscle is saying, let go. Let go. All right? We are going to be seeing more of this when we get on over to the reflex arc. So there we have it, the three type of nerve cells. The sensory neuron, it has a cell body in the middle. One like to say along the process. The motor neuron, it has the cell body at the end. Now, the sensory neuron is taking information towards CNS. The motor neuron is taking information away from CNS, while the connector neuron is moving that information within CNS from the sensory neuron to the motor neuron. I do hope that you are following the diagram in your book if you have a biology book. If you don't, just go to Google and look at pretty much the diagram of a sensory neuron, motor neuron, and of course, connector neuron. Now, like everything else in biology, they are made up of other parts. Now, I want to look at two very important things here. I want to look at the dendron and the axon. Now, I am not going to tell you because I want you to learn. Tell me, what is the function of the dendron? No matter of fact, make the distinction between dendron and axon. Axon, A-X-O-N, in the chat for me. Give me the distinction. So D-E-N-D-R-O-N, dendron versus axon. Tell me what's the difference in the chat. It's very important for you to know this, because when you get to the exam, or if you look at one of those past papers, you will realize that there is a labeling there that looks pretty much like the axon. But the difference in them is, of course, where they take the information to or from. All right? So that one we have to look at on the paper. I don't remember if I did give I don't remember what's on the paper, but if you find it, tell me what it says. So this is the lesson for you to go and scrutinize that paper. So we want to find out now what is the difference between the dendron and the axon. Are you still with me? I hope no one is asleep. Dendron and axon. And then we're going to be talking about the myelin sheath. You would have seen the myelin sheath, and it pretty much surrounds the axon on the dendron and act as pretty much an insulator for the message there that is being transmitted. Now, it is able to do this because it has a whole lot of fat deposit, and it allows also for the impulses to pass very quickly as they move or as they jump from one node to another. All right? Remember that the nerve cells, they are not connected to each other. There are some little gap between them that we call synapses or snaps. Some persons say snaps, some say synapses. There is a snap there. So remember, they are not connected together. And of course, the myelin sheath would, of course, help the impulses to pass very quickly as they jump from one node to another. Remember, I did not say dendrite, I said dendron. 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 Everybody coming up with dendrites? That's what you're hearing? I think that should be convey nerve impulses towards the cell body, axon. nerve impulses away from the cell body. All right, so dendrite receive impulses from receptor and impulses travel along the dendron. All right, Mark, not pretty much close to where we're going, Mark. Other persons are doing research, and of course, we're waiting on those to come in. We've just looked at the myelin sheet, and we say that it is pretty much that sheet that covers both the axon and the dendron. You would have seen it in your diagram there. It is pretty much an insulating sheet for the message or the impulses that is being transmitted, and it also allows for impulses to move very, very fast, and pretty much as they move from one node to another. All right. So dendrons, they carry impulses towards the cell body. Now we talk about the cell body. We are talking about the cell body of the nerve cell. So we spoke about the cell body being at the end for the motor neuron. I would say that it is along the process for the sensory neuron, and pretty much the cell body is pretty much the connector neuron seems just to be a cell body with some dendrites on it, that type of thing. All right. So the axon now, it carries impulses away from the cell body. All right. So we have to remember that when we get into the exam, though the axon and the dendron, they are going to be labeled and they look pretty much the same thing and the same long process. If you see the axon already labeled and you see something go to that same thing touching it, then that one is going to be the dendron, right? It's not the axon, it's not a mistake. One is the axon and one is the dendron. I suggest that you go to my past paper, look at the question and tell me what you saw. Or tell me what you would have seen when you look at the paper. If you have seen it already, tell me what you saw. All right? So when you look at that paper, when you are looking at the cell body, be it the sensory neuron or the motor neuron, the dendron and the axon, if you are going to know them different, it's that the dendron is carrying impulses towards the cell body. Now, the axon is beautiful. It's very easy to remember that because away, axon, the big A there, the axon is carrying impulses away from the cell body. So when you go into the exam, this is usually a trick question. I hope it didn't trick me on the paper there that I did for you. Remember that, all right? Dendrites are projection of neuron. Yes, this is a better answer. But that's not what I was looking for. I was looking for DENDRON. Dendron. Not dendrites, but dendron. All right? So we're going to move on. I'm not too sure. The research is taking a little long. I don't want you to be distracted, and we have a time bound here. We're under some control. So let's move right along. The next thing that we are going to have, we spoke just now about node. We are going to have what we call the node or the node of Rabier. And these are actually gaps in the myelin sheet that increases the rate of impulse transmission. So these are just some gaps, some little space. And of course, we're saying that they increase the rate of transmission. Then we have the ganglia. The ganglia, and this is pretty much a swelling caused by the cell bodies along the process. All right. So pretty much the dendrites, the ganglion, the node of Rabier, the axon, the dendron, the myelin sheet, these are all the parts, the cell body, these are all parts of most of a nerve cell. The dendron is a local first mark down be please stick with what I told you about the dendron. It might be something better for us to work with. All right. No, Sherrington, please revisit that. What will happen is that as you read deeper into the book, you'll find it. It might not be on the cell itself, but if you read through your notes, you will find that word. All right, it's ganglia, Ganglia. IA, ganglia. All right, good. All right, so that takes us to the point where we're going to be looking now at the reflex arc, and we're going to be looking at 3 and all right, good. We're going to be looking at the reflex arc. Now, you must have heard along somewhere about a reflex action. About a reflex action. Now, can you recall what is a reflex action? When we talk about a reflex action, what is it that we're talking about? A reflex action. All right, so it's a reflex action. I mean, I had no control over it, it just happened. So a reflex action is pretty much a rapid, automatic, involuntary action to a stimulus. So something changed without you knowing, you have no conscious thought over what has been done. But of course, something happens and it will, of course, help you. Like when we touch something hot and immediately pull away the hand. And that is only when you did not know. So if I knew that this was pretty much hot and I were supposed to touch it and then let it go, that's not a reflex action. But if I didn't know and I touch and immediately let go, then that would have been a reflex action. So usually, the key thing about a reflex action is that it is automatic, an automatic involuntary. It's not a conscious decision that we made that caused the action to take place. All right, response to action is a reflex action. Reflex action is an involuntary movement in response to a stimulus. Beautiful. Is an involuntary action that are controlled. No, Macmillan. Controlled by conscious thought. No, no. A reflex action is not controlled by conscious thought. You have no control. If it's a reflex action, you have no control over it. All right. The action is, of course, carried out usually. Okay. The action is usually carried out. Oh, I'm sorry. I can't see. Not controlled by conscious thought. Beautiful. Sorry about that, Macmillan. Sorry about that, Macmillan. All right. So usually the action is carried out by muscles, or it's going to be carried out by gland. If it's carried out by gland, where it's of course hormone, is going to be much slower than if it's the impulse that would have affected the muscle. Now, that being said, we're going to be looking at what is called the reflex arc. And the reflex arc, simply put, is the pathway between the receptor and the effector. Remember when we started, we were talking about coordination and control. I would say coordination and control pretty much has to do with what happens between a receptor and, of course, the effector. So we're going to be now looking at a reflex arc, and there is a general pathway for a reflex arc, and usually persons might read summary book and accept the general pathway to be the same thing for all reflex action. Is definitely not so. We are going to go through the general pathway, and then we are going to go through three reflex arc, and we are going to point out the difference so that if you were supposed to see it on an exam paper, you'll be very comfortable in answering the question. So the pathway for a reflex arc is usually we start out with, of course, the receptor. Remember when I hit myself, the receptor detecting that stimulus, that change in the environment, and that having picked up the change in the environment, then the sensory neuron will carry the impulse to the central nervous system. Now, having gotten into the central nervous system, then the relay neuron of the central nervous system will carry the impulse to the motor neuron. We just did that a while ago when I was playing around. And then, having gotten to the motor neuron will carry the impulses now to the effectors. Remember that effectors are always muscles or glands. Effectors are always going to be your muscles or, of course, gland. No, and of course, having gone to the receptor, having gone to the effector, which is of course muscle or gland, they are going to effect change. They are going to cause now a change. So they are going to, of course, do something in order to protect you. That is usually the case with a reflex arc. It's usually to protect you or to show that something is working well, as it were, with the knee jerk. All right. So the first one we want to look at as a reflex arc, we want to look at the cranial reflex. So it's happening up here. Remember when I was trying to point out an hammer home, the ears, the eye, the nose, the mouth, that type of thing? That's the reason I was doing that. So the first thing we want to talk about is the cranial reflex. And I'm teaching this because we just completed looking at the eyes. And what I'm going to be looking at now is pretty much what is happening with the pupil and the iris. So we're going to be looking at the cranial reflex. And of course, we're going to look at the eye, like I said. But before I look at the eye, I want to just outline some cranial reflex that you should know. I just a thought come back there. So some cranial reflex that we should know is the first one, the pupil adjustment. That's how I started out. Sneezing. You're cooking with some black pepper, there's something, some foreign matter enter the nostril. You are going to sneeze, which is of course an automatic reflex action. And then also we have like blinking the eye. Now this is not a reflex action. I'm blinking my eyes now. That's not a reflex action. I decided to blink my eyes. I have control. But there are times when the eye become very, very dry and you have no control over it and your eyes just blink. And of course, it spread the tear across the eye there in order to make it a little more moist. Now, there are times when something come very close to the eye and the eyes will blink. You have no conscious thought over that. If you did, it would have been way too slow. So in that case, blinking of the eyes would have been a reflex action. So remember, if you are just blinking the eye, that is not a reflex action. And then we have like coughing. Remember when we spoke about the epiglottis, when we were talking about digestion and we were talking also in respiration, we spoke about the epiglottis. I would say that if you're swallowing and something actually went to the trachea, got into the trachea, then you're going to have this cough. Some might say this is not the gag reflex, but of course that type of a thing. You are going to cough in order to expel that which got into the trachea. So that case, coughing, in that case, coughing is a reflex action. But if I were supposed to go, that is not a reflex action. I decided I wanted to do that just now. Sir, it helps organism to quickly adapt to an adverse circumstance that could have the potential to cause bodily harm or even death. Yes, pretty much that's what a reflection action would do. All right, so pretty much those are some examples of cranial reflex. We have the pupil adjustment, we have sneezing, nostril, we have blinking of the eyes, and of course we have coughing. List not exhausted. Anna? All right, good. So we're going to be looking now at what happens when we have a pupil reflex. So the first thing we're going to look at bright light. Now, if I were supposed to look up at that bulb, I can't, the only control I can control my eyes is to turn them left, right, up and down and around and around and around. That's pretty much what I can do. But what happens with the iris and the pupil, I have no control over it. I don't know how to do it. I don't know if you have learned to do that, but I have not. So when you are in bright light, you're going to help me here. The stimulus here is bright light. What is going to happen is that the receptors will detect that the light is bright. Then this information will be transmitted along the sensory neuron. The sensory neuron is going to take this information. You can just draw arrows like a timeline when I talk, you know. So stimulus, arrow, receptor, arrow, then the sensory neuron, that's the nerve taking the information there, and it is now going to go into CNS to the relay neuron. Now, the relay neuron is going to take this information now and hand it over to the motor neuron. Hope you are following. Now, the motor neuron is going to now take this information to the effector. We're talking now about pupil reflex, which is, of course, an example of cranial reflex. Now, the effector here is, of course, going to be the circular and radial muscle. So I'm going to pause here, not to make your life difficult, but for you to tell me what is going to happen to the pupil, what is going to happen to the muscles, the circular muscle and the radial muscle, now that we are in bright light. So remember, the last time around, we said that in bright light, the circular muscles are going to contract. So what is going to happen to the radial muscle? If the circular muscle contract, what will happen to the radial muscle? Circular muscle contract, what will happen to the radial muscle? Now we're looking at the pupil reflex, which is, of course, a cranial reflex. And we're looking at the pathway in which the message would travel, and, of course, what is going to happen at the end. So if the circular muscle contracts, then the radial muscle naturally will relax. When this happens, the pupil size will, of course, reduce. No, the answer that we're looking for is contract. So the pupil size is going to reduce. I'll do that again for you who are listening right now. So bright light, that's the stimulus. What picks up the information? The receptor. What carries the information? The sensory neuron. Where it takes the information to? CNS. When it gets to CNS, who collects the information? The connector neuron. The connector neuron connects this information. What it does with the information? It gives this information now to the motor neuron. The motor neuron now is going to carry this information where? To the effector neuron. Sorry, to the effector. It's not a neuron. It takes it to the effector. Remember that the effector is, of course, going to be your muscle and or glands. All right? Now that it has gotten to the effector, in this case, it is going to be the circular and radial muscle. There in the eye, they are going to make some adjustment where the circular muscle is going to contract, the radial muscle is going to relax, and this is going to cause the size of the pupil to become much smaller in order to reduce the amount of light entering the eye. Now, of course, that is a reflex action. Nobody said that a reflex action would have to make you frightened at all time or jump, or everybody had to know when there was a reflex action. But the pupil there, the iris adjusting and the pupil size being adjusted there, that is a reflex action, and it is under no conscious thought by you or me. I have not learned to do it, and I've been on earth for probably 5,000 years, and I still don't know how to do that. All right? So please be reminded at all time, an example of the cranial reflex is what happens with the pupil. You want to draw that pathway. You want to be able to interpret it if you see it on the exam paper. Once I would have completed a class with you every day, any day, go to one of the past paper, any one of them you feel like looking at, and of course, go through some question and see if there's anything that you are closer to mastering. Sir, the relay neuron have many short axon and dendron. Many short axon, many dendrites. It's so small that you really don't see an axon and you really don't see the dendron. It's so short. All right. Most time it is represented and you don't even see those. All right. Good. Let's. Pardon me. If I'm a fossil, I might be that. I'm gonna ask if I'm a fossil. Who knows? Probably I am, sir. Is the same root for coughing. It's going to be the same root, but let me hope that you don't understand that we are going to be talking now about the radial and the cranial and the radial and the circular muscle. All right, let me hope that we're not going to be thinking about that. But the one that is on your syllabus, biology or HSB, the cranial is going to always be the one for the eye, and it operates the same way. It's not the spinal where the withdrawal and the knee jerk operate differently. Those operate differently, and we're going to be looking at that now. And I want you to pay attention because one of these questions is on one of those multiple choice paper that we have up. All right. All right. So let's look at this one now. So the spinal reflex, the common ones that we look at or we've seen in the exam is, of course, the withdrawal, the one where you touch something hot and you withdraw. And we've also seen the knee jerk. Those are popular in your textbooks. We are going to be looking at both today. Now, I know that you would have seen them sometime or you're looking at them in your textbook now. And in your head, you are saying, but these are the same thing. Why do we have all three? They're all different. All right, they're all different, and I'm going to be showing you now. So we spoke about the cranial that has to do with the head. Now we're talking about the spinal, which has to do with the spine. So we're going to be looking at the knee jerk, or it is called the patellar reflex, knee jerk or patellar reflex. And let us look at that one very quickly. So this is the one that you use a mallet to strike here, to strike just below the patella here, and of course it will cause what we call a knee jerk or cause the leg to move forward. Anai, how long are you? Sorry guys, Anai is here. I think he wants to say hi. Oh, you want to say hi, Anai? All right, say hi, and then we go say hi, hello, hello. Hmm? All right, are you going now? All right, hi, hello, hello. All right, tell him bye bye now. Bye bye, bye bye. All right, good. Later. See you. All right, good. All right, so and I come by every now and then to ensure that the class is going well. So I have to give him his little time. All right, so with a knee jerk, the first thing you're going to have is that stimulus. And the stimulus is that sharp blow. All right, thank you guys. That sharp blow below the knee. And then the receptor, which is of course a stretch receptor, they are going to pick up this information, and of course the sensory neuron is going to take this information from them. Now, the sensory neuron is going to, of course, transmit this impulse to the spinal cord. And I'm going to explain something. It's going to transmit this impulse to the spinal cord, and the motor neuron is going to pick up the information. I pause now. You know why I pause? I want you to pay attention to this. Have you realized that we did not make mention of a relay neuron? Okay, beautiful. You are lost. Very good. It's a very good place to start learning. So I'll go again. I'm going to stand. All right. So we have this is the knee jerk. So with a sharp blow is delivered here, right? Now the sharp blow having been delivered there, that is pretty much the change in the environment or the stimulus. All right, that is the change in the environment or the stimulus. So it's your leg is hanging. You cross your leg over each other. You're sitting on a stool and it's just hanging there. So you have gotten this blow. Now this is a pathway of events of what will happen. The stimulus, the hit below the knee, then that must be picked up by something. That which pick up the information there is called the receptor. The receptor having picked up this information, the sensory neuron will take the information from the receptor. That is what we have been saying all evening. And then it is going to take it into the spinal cord. Now, the difference with this reflex arc is that here, there is no intermediate neuron. With the knee-jerk reflex, there is no intermediate neuron. There's an example on the paper. There is no intermediate neuron. So the information goes directly from the sensory neuron. Make sure you're following in your textbook. It goes directly from the sensory neuron right into the motor neuron. Now the motor neuron is now going to take this information to the effector, which is in this case is going to be your muscle. When it takes the information to the muscle, the leg is going to kick forward or move forward. Now you could just try it, get a stool in your house, sit on it, cross your legs, right? And then you're going to ask somebody to give you a sharp blow, like with the hand like that, just chop it right there. And if it is striked properly, then the leg will just kick forward. And if you have never seen it, if you talk to your parents or your friends, everybody would have, most person would have been aware or know about this type of reflex action, because as kids, we used to do it when we were playing. All right. So pretty much the takeaway here in this type of spinal reflex is that there is no intermediate neuron, but the pathway is pretty much the same, with the exception that there is no intermediate neuron. Now remember, in this type of a reflex, the information does not go directly to the brain. The information goes to the spinal cord, makes a decision, and then the information is sent to the brain. Now, the reason for this not going to the brain, if it were supposed to go to the brain, then the response would have been too slow. All right? If the information were supposed to go to the brain, then of course it would have been too slow. So first it's going to go to the spinal cord, effect change, and then it goes to the brain to record that, hey, we did something, and of course this is the result. Why there is no intermediate neuron? That is the big question. That's a very big question. And I did some research. I tried to find that out just the same. And I am yet to find the answer. So I'm going to leave this for everybody in the class to do the research. Those persons who are not logged on as yet, we want to find out why there is no intermediate neuron in the knee-jerk reflex. Remember where the intermediate neuron is found? It's found in CNS. But here with a knee-jerk reflex, there is no intermediate neuron, and we want to find out why. All right, so if, of course, if the information went to the brain first, it would have been too slow, and we would have, of course, passed out like Amoy would have said. So here, we want to find out why, with the knee-jerk reflex, there is no intermediate neuron. And that is going to be our assignment for the next class. But before we get to the matter of the next class, we want to look at the withdrawal. Now, this one is with the hand. So the first spinal reflex that we did was with the knee jerk. And now we're going to do another spinal reflex, but this one is with the hand. I do hope that you are following in your text, whatever textbook you are using at school. All right, or at your classes. I do hope that you are following, because remember we said that we don't really use pictures and so on, because we'd have to pay for these pictures and the copyright infringement and all of that. And drawing sometime, you know, I am in and out very fast. So that type of a thing. So remember, you are supposed to follow in your textbook. One day, one of these persons will, of course, sponsor the program, so I can shout out a name textbook that is the preferred textbook to use. So if you're listening and you want to sponsor the program, hey, we want to see you on board. We want to have you on board. All right, so the withdrawal is now with the hand. So we spoke about knee jerk. That was with the leg. Now, sir, my book don't have much on all the reflex. Depending on which book you are using, that might be true. And of course, yes, if you are using a summary book, you are going to be having problem on a knee jerk and spinal. All right, we know that. And in some of these books, they only have the summary. All right, so just follow the pathway and draw the pathway that we gave just now. And if you follow that pathway, it's fine. You don't really have to have it in your textbook. It's good. All right, so the withdrawal. It is pretty much like all the others. In this case, we have the relay neuron. So with the spinal reflex, with the withdrawal, there is a relay neuron. With the knee jerk, there's no relay neuron. So withdrawal, we are going to have the stimulus, then we are going to have the receptor, sensory neuron, information getting into CNS. The relay neuron is going to take the information, give the information to the motor neuron take the information to the effector, and then there's going to be a response. And you know what is going to be the response? The response is going to be you pulling away your hand. All right, so that is pretty much very, very easy. I could do it again. Stimulus, which is the heat, that high temperature. Stimulus, receptor, the skin going to pick up the temperature. Of course, the sensory neuron is going to take that information into CNS, the spinal cord, preferable to say. Take it to the spinal cord, make it very easy for you. And of course, the relay neuron will get that information from the sensory neuron. Then it's going to give this information to the motor neuron. The motor neuron will send the information to the effector, which in this case is a muscle, and the muscle will say, listen to me, let go off of that thing. It's really too hot for you. All right, beautiful. So the next thing we are going to be looking at, so that takes us through all of the reflex action. Please go through them again. Remember, I said earlier that there are a couple of reflex action on the paper, some with diagram, some without diagram. Just go to any one of the videos that we have worked. And remember, we said something. Which are the questions I said that we were supposed to look at? We were supposed to look at one with the axion and the dendron. I will want to check that one again. I'm thinking, I don't remember how I answered it, but I just look at it. And if you look at it, I'll know that you watched the video and you can tell me which question we have concern with. And the one that you asked about respiration, where your teacher is saying it is something else and we are saying it is something else, I am going to be providing, if not today, by Sunday, I'm going to be providing direct literature and, of course, all the evidence that you need to support our answer, not only in the description and the comments, but we're going to be doing it on the show come Sunday to prove to you why it is so. Remember, we spoke about you could tell your teacher about the advantage of playing in the Azteca. The Azteca is that stadium in Mexico. When persons are going up to the top of the Azteca, they don't walk, they drive. However, when they go up there, they can't beat Mexico because Mexico have that advantage. In order for you to play up there in the Azteca, you have to be up there for at least 2 weeks so that you build up more red blood cell, or you are going to go into an oxygen chamber. And those are some of the profound things that we use to defend our answer with that question. It has nothing to do with being tired. No, it has nothing to do with being tired. And we're not the only person. Which other paper you say it was 2015? If it's 2015, it's a panel teacher who answered that question. She said 2015. 2015, it was Bryce and some other biology teachers and McLeod and so on. All right, so it was a panel teacher who looked at that paper. 2015, we had a panel of teachers who worked on that paper. All right, so we're sure. Question, somebody said 2015. 33. So let me go over there and look at 2015. Sorry, guys. The last thing we have for the show, we're going to finish within the next 15 minutes. We have types of action. We're going to be looking at voluntary action, involuntary action. We are going to be looking at condition reflex. All right? Condition reflex. While I go over and come back and do the little break that you can get your little water, just look at what is condition reflex for me and you can type it in the chat. I'm going to be looking at 2015 33 and see what we did there. No, that's not the one. This is the myelin sheet. This one is the myelin sheet and the axion. What is the question asks? The label part is the axion. No, that is not the question. That is not the that I'm looking for. I think the question that I'm asking you to look at is on one of the later paper that we put out. It could have been on, what were the two last papers? 2020 and... Look for about the two last papers. 2016 and 2020, something like that. I think one of those papers will have some interest there. So look at that nerve question for me and tell us. No, remember, we don't have the 2018 paper. Somebody sent me the 2018 paper recently and we have some missing question. So if you have all the 2018 paper, just email it to the channel email address and we will work it and put it up. We don't have the 2018 paper. Please send it to us. Go on over to the back end, go into about when you go to the channel. Go down to the bottom, you will see email address. Click on email address. You will see the email address come up, or if there's somebody here who have the email address, just put it in the chat that other persons can get it. Good night. I am new here. Can you tell me the days and time? All right, so they're answering your question. It's usually at 5:05. And of course, it's a big community, so we know everybody here. So when you come, or if you don't come, we're going to miss you. So once you join and become a part of the family, we just look out for you. We want you to be here every time thereafter. All right. So that one is all right. The 33 that you showed me a while ago, I think it's on the 2016 or whichever one we put out before. We might have a question. We might have some challenge there. I don't remember what I did on the paper, but the one that I told you that your teacher is having problem with, tell him to go and do some research on the Azteca and do. It is a respiration question. It's a respiration question. We are going to be providing you more information on that, and we are going to be working with your teacher as well. And we are open, even though we are so convinced that that is the answer, we are open to listen to your teacher. Remember, we are not posing that we are the keeper of knowledge. And remember, with enough respect, we respect your teacher. And don't go to your teacher and be any type of rude thing to your teacher. We are open to the conversation. And like I've always said, when it comes to multiple choice has a story behind them. And if you don't get the story right, you might think that it is something else. Because with multiple choice, there are always two answers that are very, very close. And in this case, these two answers are very close. And why one would get it wrong? Because we have not gotten the story. At times, I miss the story behind it. Yeah. And that is why I've said to you, when you look at these things, look in the description, look in the comment to see if there's any adjustment that we have made. And if you have something that you think that, hey, sir, not do this right, send it to us. Don't say that sir is the brightest man in the world, so I can't question him. You can always question Mr. Wilson. I am not the keeper of knowledge. I'd love to be, but I am not. All right, beautiful. So we move on, and we're going to be wrapping the class now. So we're going to be looking at types of action. And when we talk about voluntary and involuntary, you remember that we spoke about voluntary muscle and involuntary muscle when we look at the skeletal system. Now, a voluntary action is, of course, an action that we decide to carry out. So I am deciding now that I'm going to be talking to you. But now I'm going to decide that I'm going to be silent. I decide I want to lift this bottle up. So that is, of course, example of voluntary action. Now, with voluntary action, the impulse usually begins in the brain. You make that conscious decision that you are going to do it. You make that conscious decision that you are going to do it. Now, there's also involuntary action that you have no control over. We spoke about those with the reflex action. We looked at the cranial reflex. We looked at the spinal reflex. Those we have no control over. But there's another long list of things that happen in the body that we have no control over. They are, I am doing bio and maths in Wednesday and Friday. Okay, we do bio HSB all these days. If you can't be at the class, just catch a replay. The replay is on the channel. We don't edit any other videos. It's a real life class, so we don't try to cut out anything. All right, just have the experience and move forward if you so desire in the class. But we're happy that you're here. All right, so we were saying that there's a long list of other things in the body that are involuntary. We have no control over it. Like when you are in, I just know Guyana. Only Guyana tell me the dish that they like. They say they eat hot pot. What called pepper pot or something like. I don't remember. Pepper pot. Somebody from Guyana, tell me what's your favorite dish over there. So when we get that favorite dish and we're eating it, and it goes down, and it goes down, and it gets down to the esophagus here, we have nothing else to do with it. Everything thereafter is involuntary action. Peristalsis, involuntary action. So we're going to look at some of those involuntary action that pretty much is taking place within. Remember that trembling is also a reflex action. It's an automatic reflex action, or it's an automatic action, involuntary action that generates a whole lot of heat in the body. But we're going to look now at these actions. I'm going to introduce a new word now. Listen carefully. Listen carefully. autonomic, not automatic. When we talk about reflex action, we say automatic. Now we are talking about some involuntary action, and we are saying that they are under autonomic. They are part of the autonomic nervous system. Autonomic with an N. Autonomic. Now, these are controlled by the part of the brain around the back here. We're going to be looking at the brain later. That is called the medulla oblongata. So at the back of the brain here, look at the diagram of the brain. It's called the medulla oblongata. Now, it is responsible pretty much for these involuntary action. And we say that these that I'm going to be looking at, they fall pretty much under the autonomic nervous system. And it pretty much control all the internal action which have no conscious control. And these include peristalsis, pretty much the squeezing down of the food. That is the easiest way to put it, of the food through the gut or the alimentary canal. Then we have breathing. I mean, when you fall asleep, you have any conscious, you control how you breathe. You're telling the body, oh, I just want to breathe at this rate, and then I don't want to breathe too loud and that type of thing. I don't want to go too fast, and no, you have no control over that. Then I'm seeing big word. Then I'm seeing here another thing. Oh, autonomic. Same auto, N-O-M-I-C. Autonomic. So A-U-T-O-N-O-M-I-C. Autonomic. All right. So I'm seeing here heart rate. Yeah, you can go outside and decide that you're going to run up and down and increase the heart rate. Yeah. But pretty much that's not something where you do like you lift up your hand like that. You do it and then the body do everything itself. So it's under the autonomic control that it determines what to do and how to do it and how much of what it needs. So we have peristalsis, we have heartbeat, we have breathing, we have the homeostatic or homeostasis responses. All right. So these are examples of the things that are under autonomic control. It is not something that we think about. No, it's not something that we think about. They just happen by the body's own mechanism. And they are all considered to be involuntary action. Now, the last thing we are going to be looking at for this evening, and then I'm going to ask you to have yourself a safe and wonderful weekend, is of course conditional reflex. Now, conditional reflex are things that you have to learn at first, but after you would have learned them, there is no conscious thought in doing them thereafter. So an example of conditioned reflex would have been walking. When you were a baby, you couldn't walk. You were there on your back and somebody probably had to turn you. And then you started learning to do that by yourself. And then you started doing a little creeping and somebody had to help you here and there to stand up. And then you learn to walk. And then once you learn to walk way back then, 10,000 years ago, you are still walking up to today. And when you are walking, you don't think, okay, I'm going to put my left foot here. I'm going to put my right foot there. Oh, careful, I'm going to fall. Oh, no, don't put it. No. You just keep walking, 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 walking. And you're so good at walking now that you start running. So once you learned that, after that, it became something that you didn't have to think about. And that's an example of conditional or conditioned reflex. Conditioned reflex. Now, you remember the first time you got on a bicycle? Oh my, you went on and you just tilt to one side and then it went to the other side and then to the other side. And oh my, am I ever going to learn to ride this bicycle? And you ask yourself, and then you try it again, and oh, the bicycle just went down the road, and you're like, oh, how did this happen? And you come back and then you try again, and you drop off, and probably you hit the head and or bruise up your knee or something. And you decide, I am never going to ride a bicycle again. And then you forget about that bruise up knee, and you go on the bicycle, and then you start moving, and then you start to pedal, And then yes, the bicycle start going, and that day you just ride it. I mean, that day you just ride and ride and ride and ride and ride. You're just riding, and then thereafter, you didn't have to think about it. You just got a bicycle and you just start riding. An example of conditioned reflex. Thanks very much for joining me this evening. It's Mr. Wilson Live, and we stream on a Wednesday, Friday, and Sunday at 5:05 p.m. If you like what we do, it's a free class to any student in the Caribbean. Free, free, free. We don't need to know your name. We try to ask where you're from just to find out how far our reach is. Now, join us on any of these days. And if you have not yet and you like what we do, please like, share, and subscribe. Now, be reminded that we have a whole lot of video on the channel. We have some 150 videos on the channel with animations, and we continue to make videos as persons ask us to do. Now, another thing, we have a whole lot of live session that we would have covered topic by topic by topic. You can just go onto the channel and look for the lives. We have started putting them in volume, and also on the volume will tell you what topic or what part of the lesson we would have covered. Now, we're going to be doing some more biology in, of course, irritability and coordination come Sunday. The topic might take us into next Wednesday. We're not too sure because we really don't want to go too fast and then we're losing everyone. We want to ensure that everybody is, of course, on board. So remember to like, share, and of course, subscribe. If you have not yet liked, do it now. If you don't share, do it now. If, of course, you know, subscribe, time for you do it now. This is Jamaican Creole. Time for you do it now. And of course, if you have not told a friend about CSEC Biology, the cover page, do it now. And if you have not yet advertised for us in your WhatsApp status, go on over to the channel, look for one of our ads. I think we have 3-4 different ads on the channel. Get the ads, put it on the status. I think it's the link you're going to put on the status. Copy the link from YouTube, put the link on your status, and say, "Oh yeah, man, that's my class. I'm Mr. Wilson. That yeah, Mr. Wilson, the Jamaican guy. Yeah, that fella there. Yeah. Him thing, him thing. I go on. Yeah. We're doing well. Thank you very much, guys, for being a part of the family. Thank you very much for the trust that you have. Amoy, is integrated science similar to HSB? As it suggests, integrated science is an integrated science. Like, share, comment, here, response, and subscribe. All right. I'm looking at something there that YouTube flagged just now. Thank you, sir. All right, good. All right, good. Integrated science, as it suggests, integrated. It's a mixture of chemistry, bio, physics, and I think it might have a little geography or a little agri in it. I don't remember. But I know that's what it is. I don't want persons to understand HSB to be a subject that is a subset of biology. It is not. They might be very, very close, and a lot of things might be the same. But if I were supposed to tell you about what HSB is, I'll say that HSB is like the CSEC version of environmental science at CAPE. So you have CAPE biology and you have CAPE environmental science, and I would say that HSB is something more like the CSEC version of CAPE, right? So usually integrated science, it will have a lab. It has a lab. Physics has a lab. Chemistry has a lab. Bio has a lab. And of course, HSB, if you are in grade 10, if you are going to be doing the exam next year, now HSB has a research paper to hand in as well. All right, so that's what it is. So if you want a mixture of all those subjects, integrated science is good. But what is it that you want to become? Because that is going to inform the decision that you make. You are doing HSB already. I don't know. What I like to tell students is that if you're going to study at any institution, find out what is the requirement. What is it that they want? Don't just go out and just do 500 subjects, a million subjects, and then you really didn't know all that. But sometimes too much information is not the best thing in the real work world. Too much information, you learn too much, you're too bright, you're just going to be exploited. And you're going to get the same pay like the person who knows just one word. Yep, true. All right. So that's going to be it. I'm not sure if we have any other question. We are working. Um, dental hygienist or nurse. Where are you going to study? All right, I think the University of Technology is one of those big brand in Jamaica for that. So you need to contact the University of Technology to find out more about those areas. I think they do nursing. I know you will do nursing as well. So UTech, all right, cool. So if you are going to be studying at UTech, you want to go there. I know that they have a nice handbook or a nice brochure or whatever it is called. You can go and get that and see the requirements and make sure that you apply early. Remember, you're applying for college before you actually pass the exams. So if you are going to UTech, you would have applied somewhere January, February, thereabout, and then you are going to do the exam. And once you're successful, then you will move right in. But you are going to be successful, so it is time to apply. Remember, you apply for colleges in January, February, thereabout, not in September. All right. All right, Sherrington, big up yourself. All right, so that's going to be from this evening. Thank you very much for joining. I see you on Sunday. And remember that on a Sunday, I am traveling from Yonderland. So if I am not here on time, just forgive me. I really don't want to push by the time for the show because those persons who are in Guyana and those persons who are in Trinidad, they are going to suffer um, if I were supposed to push back the show. So for that reason, I don't want to push back the show. I have to keep it at 5 so that I can meet their needs as well. Thanks again, everyone, for joining. Good evening. The study guide will come out shortly. Should come out by, well, I could work on it this evening, not too sure. It should come out sometime in the week. And for those persons who are doing biology, we are working on the planning and designing lab report. And of course, the skill as to how you should carry out the planning and design lab. That is coming out. It's way advanced. We are working on that. We're also working on the mark schemes so that you can have a good idea. You could ask your teacher to look at it. So you have a good gauge as to what is expected when you are doing the lab for biology. So we have the PD lab coming out shortly. Please make use of the ORR skill that we have online. We have MM online. We have drawing online. I think yeah, and we have labs that are written up and explain lab report. So go on over to the back end of our channel. Go on over to the back end of our channel and look for the labs. The labs are there. We have labs separate from the skills. So we have the skills that tell you what is expected in the lab. So you go and look for ORR. There is MMI said. In the ORR, you are going to find AI. It's a mixture of AI and ORR. Measurement and manipulation is on the channel, and we've had that here for a long time. Diffusion lab, we wrote a diffusion lab from start to finish so that it provides a good guide as to how the lab is supposed to be written. So if you go there, that video is doing very, very well. So go on over lab report, search the channel. You guys are subscribers, so you can go over and check for whatever video you want. Just go to the back end of the channel and look for whichever video you want. Look at my long playlist. All right, like I said, there's about 150 videos there, and plus the live, which is another large amount. All right, so it's evening. Bless up. Me gone. Bye bye. Tata.